Today I'm going to share with you how to find a probability based on a normal distribution curve using the graphing calculator, TI-84 Plus, and I'm going to do it two ways. I'm going to do it just finding the percentage, and then I'm actually going to draw the picture to show the percentage. So I have an example here from a textbook, Mathematical Studies, and it says that the waiting times for an elevator are normally distributed with a mean of 1.5 minutes, standard deviation of 20 seconds. So what I think I'm going to do is turn this 1.5 minutes into seconds, so a mean of 90 seconds. Sketch the normal distribution diagram to illustrate this information, indicating the mean, the times within 1, 2, and 3 standard deviations. Then, find the probability that a person waits longer than 2 minutes 10 seconds for the elevator, or a person waits less than 1 minute 10 seconds. 200 people are observed. Calculate the actual number of people expected to wait less than 50 seconds for the elevator. Okay, here we go. You can see here that they've drawn the distribution for you. The mean is right here at 90. And then they have 1 standard deviation, 2 standard deviations, and 3 standard deviations in both directions. So I'll leave that at that. What I'm going to do is jump to the second part, find the probability that a person waits longer than 2 minutes and 10 seconds. So that would be 60 times 2, 120 plus 10 is 130 seconds. Okay? So having the calculator on, I want to go to the distribution. And I will go down to the normal CDF. And in this area, I need to put my lower bound, my upper bound, my mean, and my standard deviation. Okay? So let's think about this for a minute. My lower bound. If they wait longer than 2 minutes and 30 seconds, then 2 minutes and 10 seconds is my lower bound, which is 130 seconds. My upper bound needs to be as large as possible, so I put 1 second. So this is times 10 to the power of 99. My mean, 90 seconds. My standard deviation was 20. Enter. Paste. Now if you didn't see the screen looking like this and it just showed the normal, then you have to put in the values with a comma in between. So we put in each value 130, comma 1E 99, comma 90, comma 20, end parentheses, and enter. Okay, so here's our value. Multiply this by 100 and you'll see your percentage. And you have 2.28% of the time people would wait longer than 2 minutes and 10 seconds, or a person chosen at random. So now what's the probability that a person waits less than 1 minute and 10 seconds, so 70 seconds? Go back. Do it again. Okay, now my lower, because it's less than, is -1 to the 99, and my upper is that 1 minute and 10 seconds, so 70 seconds. My mean has not changed, my standard deviation has not changed, so I'll just paste it in there. Enter, and times 100. So 15.9% of the time, people will wait less than 1 minute and 10 seconds for the elevator. Okay? 200 people are observed, and the length of time that they wait for an elevator is noted. Calculate the number of people expected to wait less than 50 seconds. Okay, so once again, distribution. Less than 50 seconds. So my upper is 50. Nothing else has changed. And I have 2.27, 2.28 of 200 people. So 0.02275 0.0062 times those 200 people, because that's probability times the total population, is 4.5. So we would expect 4.5 people, 5 people, to wait less than 50 seconds out of all those 200 people, because 2%, 2.27% would wait less than 50. Okay. Now, in order to look at it as a graph, let's just look at finding the probability that a person waits longer than 2 minutes and 10 seconds. Now, first thing you have to do when you're going to graph this is you have to look to make sure you don't have anything else plotted. You don't want a function plotted, and you don't want any stat plots on. So you need to make sure those are all off. Okay? Next, and this one will always be on. I'll just show you real quick. Plots on, always on. Don't worry about that. All right. Now, what we need to do is we need to set up the window that we want to look at. And remember, this is really just a one-dimensional, right? We just have these values down here. This here is going to be very small. So for this particular problem, I have my window set up. The x scale goes from 0 to 200. I can see that. I can add 3 standard deviations to my mean, and I can see what value that is and then go a little bit higher. Maybe it goes 4 standard deviations just so you see everything. I'm going to scale it by 50 so I don't have a lot of marks down there that will distract me from what I'm trying to look at. What's important is that your y range is very small. So in this case, I'm going to go from 0 to 0.03. We may find that something even smaller works. Then my scale will be 0.01s. Okay, so you have to make sure you set that window up first. Second, distribution. I'm going to go over and I'm going to draw the normal shade. Okay, so it's going to shade the normal distribution with the values that I give it. So my lower bound, if I want the probability that they wait more than 2 minutes and 30 seconds, my lower bound is actually the 130. My upper bound is 1 times 10 to the power of 99. My mean, we said, was 90, and my standard deviation is 20. Okay, and you can see right there it shaded it, and then it gave me the area. Okay, but you could see that it's shaded over on the side. Now, before you go on to your next question, what you need to make sure you do is you go back and you erase what you've done. Draw, clear. So it's gone. So now we can go back in. I'll do this last question. People that waited less than 50 seconds, I'm going to draw. My lower bound is going to be very small. My upper is 50. My mean was 90 with a standard deviation of 20. Enter, draw, and now it will redraw the picture. Let's shut the second one. Now, if that happens, and it gave me the answer that I had before, the only way that I know right now to fix that is to actually go into second distribution, do a normal PDF, just hit enter. It's going to give you an error. It's fine. Just quit. Go back, clear your drawing. Okay. Distribution, let's try it again. Draw, upper, 50, 90, standard deviation of 20, and let's see if we can get it to work. See, and now that works. So if anyone can give me any insight, I've done some research and looked around and I can't seem to find out why that happens. I don't know if it's this new software in there or if it's just the way, if there's something I'm actually doing wrong, so any input would be helpful. But that's it for now.